Hi everyone, welcome to I think the fourth work session. This is the second work session that is being taught by me. So in the previous lecture, I had introduced you to basic features of Numpy, Pandas, Matplotlib, and SciPy, which are four libraries of Python that you will find extremely useful. In fact, you will not be able to do data science without these libraries. In this exercise, in this work session, what we are going to do is we are going to try out some of the exercises that are there in this nice collection, 101 NumPy exercises for Python. I believe this has been announced on the platform yesterday, so I hope some of you have had time to go through these. And so after about 40 minutes or so, when we try out these things, I can pause and then we can take questions if any of you have any specific questions about some of the exercises on this page that you don't understand. One of the things that should be mentioned at the onset is that anytime you try out a solution from the internet for a programming problem in Python and you find that maybe even copy pasting the exact code does not work, then one of the first things you should check for is make sure that you're using the same version of, or because between different versions of libraries in Python, there are some small changes in how different functions are implemented, and you should adapt to the actual version that you have on your computer or in the collaboratory notebook that you're using. And to do that, what you can do is you can print this and it will show you. So the version of NumPy that we are using in this notebook is 1.19.5. This is actually something you can do with any library in Python. You can import X as Y, and then you can print Y dot underscore underscore version dot underscore underscore, and it will tell you which version of that library you're using. And that is, it is one of the first steps to do if you find that some solution that someone on the internet is proposing to a specific coding problem is not working for you. Make sure that you are using a solution that is meant to work on your version, because between, like I showed you last time, NumPy has many sub-libraries like random for random number generation, etc. And for different data types, and some of those sub-libraries, their functionality of specific functions have evolved over the years. So you should adapt to ideally the latest version, but you don't have that choice depending upon which system you're working on sometimes. So just make sure that if you find a solution for a problem that doesn't work for you, you are using the same version of this was also some of the questions I got earlier. It was some syntax issues that were different between different versions of NumPy. So this is a number that you should keep track of and make sure you're aware of if you run into problems. Otherwise, you don't need to care usually. If there are no problems, this is irrelevant, but if you run into problems and start having to debug, then this is a number you can keep track of. So some of the quick things that will help you when you're working with large numbers of arrays is how to efficiently work with them. So for example, if you want to replace, let us declare an array like last time, and you can see now that this array contains all the numbers from 0 to 24. So it is the first 25 natural numbers when you use a range. Now, if I ask you to replace all the odd numbers in this array with -1, here is how you would go about it. So as I explained last time, you can perform logical and arithmetic operations on an array, just like you do it on a standard variable, as long as it is a Numpy array, not with a list. What happens is the operation gets performed in an element by element way. So if you, for example, do R times 2, you'll get an array in which every element is twice the value of this array. But if you want to replace all odd numbers with -1, what you should do is, of course, there is the operation called percentage, which gives you the remainder of dividing by 2. So if you do 0 divided by 2 is 0 and there's no remainder, 1 divided by 2 is 0 with a remainder of 1, which you get. 2 divided by 2 is 1, but with the remainder again of 0, so you get that. And so you notice that by just doing percentage 2, you have located every element which has a remainder of 1, which is basically your odd number. And so if you now do a logical operation equals to 1, you get a Boolean array of the set of all numbers, which corresponds to the situation where it is true when your numbers are odd and it is false when your numbers are even. And to replace the values of this array in which are odd with -1, all you need to do is you need to do this. So you can do this in a single line once you understand the logic. So I have done so. Let us see what you have here. Now, one of the things you must have noticed is that when I'm working on a notebook, I can just type out a variable and identify a name like this and run, and I will get what that identifier stands for. This will not work if you're running Python code in an interpreter in your command line. There, if you wish to print out what is in an array, you should type out print. So I will often, out of habit, omit the print statement and just run a cell with just the identifier name in it. This may not always work depending upon the environment in which you're practicing Python, so be careful of that. So to once again, to go through this, we had an array. We declared an array in which every number from 0 to 24 was there. Then we applied the operation %2 to it in such a way that which is an operation that gives you the remainder when divided by 2. And then we applied the logical operation equal to 1, which when applied to a Numpy array gives you an array of Boolean values, that is trues and falses, corresponding to a situation where this condition is satisfied. You use that as an index to array. So just to go through this again, if you had, instead of replacing it, just done this, it would have printed out just the elements of this array where this is true, which are the odd numbers, the 1, 3, 5, 7, 9, 11, all the way till 23. And now, if you replace this with -1, you get an array in which all odd numbers are replaced by -1. You may right now wonder why this exercise is even useful, why I'm bothering to teach you something like this. But well, when you're working with large data sets, which is something we will do in probably the next work session or so, a real example, you need to be able to do operations like this on the fly in a quick way. without using for loops, because like I said, a for loop in Python is extremely slow and you should never use it if you're doing data analysis, especially with large data. And I am just trying to help you develop the logic and intuition for things that you will be using later. So as I showed you, here you can see that now every odd number has been replaced with -1. In the process, the array you first declared has been now replaced with this new array. If you want to instead do
Sir, hello, sir. Video is not visible.
Sorry?
Video is not visible, sir. Can you?
You cannot see my screen?
Screen is visible, video.
What do you mean by video?
Your camera is off, I think.
Oh, but do you want to see my, okay, sure. Sorry. Is that important? 1 second. Yeah. Yes. Hi, I'm here. Sure. Okay. Yes. So, yes. So you will notice that the identifier for the initial array that we declared is now the same identifier contains an array in which all odd numbers have been replaced with -1, for example. If you want to instead do this without affecting the original array, that is, you don't want to change array, you want to get a new array in which this has been done. Of course, one of the simplest things you can do, and I see no reason to teach you an additional way, would be to just declare. So let us create this again. You can declare a second variable which contains the same, and then you can carry out this for only the second variable. But let us examine what happens, because in some of these situations, I'm also not sure, because Python. So let us look at now. Yeah. So what is happening now is when you normally do when you assign an identifier to another identifier in Python, it does not create a copy. It just creates another reference to the same position in the memory, which means that any operation you perform on R2 will also reflect in R1. If on the other hand, you want to now get a second array, which is a copy of array 1, you can try this. What is now happening is that you get both your original array and, I believe, yes. So this is one of the ways, but I would like to instead introduce you. So let me just go through what I did once again. You have an original array, which we have declared as before. It's just numbers from 0 to 24. Now I'm using, instead of just using the equal to sign to assign a new identifier to it, I'm using np.copy, which means that now these two are two different arrays which currently happen to have the same value. Then I'm replacing all odd numbers in array 2, R2, with -1. So R is now completely unaffected, whereas R2 has the properties that you want, which is odd numbers have been replaced with -1. Notice that if I did not use this np.copy, if I just used R2 equals R, then both of these would show the same, and it would be this, because all operations you perform on R2 would reflect on R1. And these are, These are things I emphasize because most people learn Python by just trying things out, and you will occasionally run into errors that require you to know these sort of nuances. So I'm emphasizing this. But another way to do this is by using what is called np.where. So I can do out, which is a new array equals np.where. First, I will give it this is the condition that I want Python to check. This is the value that I want it to replace those points where it is the condition is satisfied, and this is the input array. Now, if I do this, I believe I'll get the same thing. So if you now look at array, you get an array, you look at out, you get an array which has the odd numbers replaced by -1, and your R is still preserved, right? So I just wish to emphasize the nuances of this again. In normally when you use the equal to sign to assign one identifier to another one, like I did, let's say before I used np.copy here, what happens is Python just gives a memory reference, which means that any operation you perform on the second one also is reflected in the first one. If you don't want that, you can use np.copy to explicitly make a duplicate array which contains the same values. Alternatively, you can use a built-in function which performs, and this is a very powerful function in the sense that whatever you give it here can be any kind of array. It can be a two-dimensional array, it can be a hybrid array with multiple data types, what is called an ND array, etc. And you can give it a condition to look for, and you can give it this value. And because this is a function that explicitly creates a copy, you get a new one in which all your elements have been replaced without affecting your original array. Your original array remains unchanged, while the output you get is a new array in which the outcome you want, which is odd numbers have been replaced by -1, has been achieved. So this is now that we have gone through that, I will consider the first step of this exercise completed. Let us look at how to stack two arrays, and this is quite simple actually. So you have R, which is your first array, and then you have R2, which is your, which is your second array. Numpy contains two functions. First one is called vstack, which will allow you to stack two arrays horizontally. Vertically, because it is vstack stands for vertical stacking. So notice that what you have to give it is a list of two arrays. So R, R1. Let us now examine, R2. I did not declare R1, so it should be. Let us examine what we will get here by printing this out. You'll notice that you get a two-dimensional array in which your first row is your first array, and your second row is your second array. If instead you use R4, equals the same thing, but use np.h stack. This is for horizontal stacking. So the v is for vertical and the h is for horizontal. And if you do this now, you get R4, which is, you get a one-dimensional array, which is now which has a length, which is the sum of the length of the two arrays you pass to it. And it is the second array put after the first array. So notice that it goes from 0 to 24 because that's how we declared it. Then it goes from 0 to 24 again, but with odd numbers replaced by -1. Now, as you can imagine intuitively, VStack will work only if both arrays are of the same length. Because, so let us actually try that just to make sure I am correct about what I'm saying, because sometimes when I say things about Python, I turn out to be wrong. And the only way to do that is to actually try. And so let us now do R4 equals stack R comma R3. So I notice that R is this array from 0 to 24, and R3 on the other hand is, R4 on the other hand is a one-dimensional array with twice the length of it. So there are 50 elements in it. And if I now try to restack them, I will most probably get an error. Yes, I get an error because the length does not match. So you cannot create a two-dimensional array in which your one row has a different number of elements from another row. This is intuition. You can, however, use this. For example, you can use hstack, because even if the arrays are of different length, you can just concatenate them together, right? So if you now do this, there is no error. And let us look at what is in R4. What I believe you'll have is you have all numbers from 0 to 24. Then you have the whole thing again, because R4 was itself created by horizontally stacking two arrays together. So yeah, rule of thumb, vertical stacking requires both your arrays to be the same length. Obviously, horizontal stacking does not require that. It can be any arbitrary length. However, you can probably use VStack to stack together a two-dimensional array and a one-dimensional array. Let's just make sure that you can do that also. For example, you can use R5 equals R comma R3. Let us see if this is going to be a problem. So if I check now, what is that? Yeah, so I get a two-dimensional array in which the shape is, there are 3 columns. So you can use vertical stack to stack a 1D array and a 2D array together, as long as the number of rows is the same. Just to make sure you understand exactly what I'm talking about, I'm going to use np.shape of R to illustrate this. You notice that this is 25 times one-dimensional array, whereas if I do np of shape of R3, you see that it is a 25 times 2 into 25 dimensional array. And now if I do 5, you see that you get a 3 times 2, 3 into 25, an array of shape 3 into 25, which is 2-dimensional. So that's all for stacking arrays. Most often how I use hstack and vstack is to actually declare multi-dimensional arrays, because if I want a container to hold a certain amount of data of a specific shape, This is how I make it. I usually use np.ones or np.zeros to make placeholder arrays, and I stack them together. Now you can also, for example, so another thing you can do is you can reshape the array, because you saw here that if you use np.shape, you can get the shape of an array, which in this case is 3 times 25. So 3 rows, 25 columns. If I want to reshape that into, let's say, so let's now try rsr equals, so r is for reshaped, just np.reshape of now I have to give it a new shape. To be honest, I don't know exactly how to do that, so I'm looking this up. Let us try zero comma 3. Okay, it's telling me it cannot reshape array of size 75, of course. That's because I was giving it. So let us try this now. Maybe what I need is I will try, let's try this one. So, okay, it has run without an error. So let us try what you get in RSR. So it was exactly the same as before. Okay, let's try now. Yeah, so notice what I have done. Your array 5 was an array which had this shape. It had 3 rows. It had 3 rows of 25 columns each. And I have reshaped it into 25 columns of, when I specify -1, what I'm telling the function is pick the number of, it has 25 rows, and I'm telling the function pick the number of columns that are required yourself, because I believe I could probably give it 25,3 and it would give me the same result. But if I try to give it 25,2, it will complain. And this is because, there is no way to, you can't reshape an array with 75 elements in it into a 25 cross 2 array without losing data. If I give it 25,3, it will give me an array which has 3 columns and 25 rows. I can also give it, for example, let us try what are the other ways you can 15,5, because and I get 5 columns, 15 rows. I can give it 5,15, and you'll notice that I'll get 5 rows of 15 columns each. So this reshape is a powerful tool to turn any given Python function, Python Numpy array into an array of a different shape. Like I told you in the last lecture, almost all NumPy functions can be used also for pandas data frames. They are, in fact, pandas is built on NumPy, and this is why I'm giving you more exercises with NumPy than with pandas, because even though finally when you open a data set and you work with it, it will mostly be on pandas. The underlying logic of pandas is built on NumPy. So understanding NumPy is the most important step towards understanding pandas, at least in my opinion. So that is about shaping. Let us now look at, for example, getting items in common between two NumPy arrays. So we have already two arrays, R and R2, declared. Let us examine what they contain again. R2 contains all numbers from 0 to 24, but with odd numbers replaced by by -1, and R1 contains, R contains all numbers from 0 to 24. Now, if I ask you to find all the elements that are in common between the two arrays, one of the things you can do is you can, of course, use something called set. This is really a mathematical operation. For those of you who have done set theory, if you do set, you don't get just the elements that are in common. You get all the elements, but without double counting. So this is not for the purpose that I just mentioned. I got carried away. I'm sorry. Let's see. R6. So this gives you, what does it say? Yeah, okay. Set does not work that way. What it can do is, for example, so if I give now set of R2, it will recast R2 into a set. Let us see what is contained in it. You'll notice that it contains all the elements in this, but with the -1 counted only once. And this is because, in a mathematical set, you cannot have duplicate elements. So a mathematical set is very much different from an array. If you do type of this R6, you'll notice that this is not a NumPy array. I believe, yes, this is explicitly a set. So if you want to turn this now into a NumPy array, you can do this is something I showed you last time, but just reminding you that you can convert between data types into NumPy arrays by using .asArray. But back to the problem at hand of finding out what are the elements in common between two arrays. So what we will do now is we will use what is called the set intersection operation, which is available in NumPy. So we will do R8. So the problem I'm setting you is very simple. This contains all numbers from 0 to 24, and this contains numbers from 0 to 24 in which odd numbers have been replaced by -1. So the common ones in between are the even numbers, and I want a set that just gives me, I want an array that just gives me the ones which are in common, which are the even numbers. So I will do intersection, I believe, yes. So there is a function like that. So if I do this, I see that R8 is everything that you desired. So as in it's basically what I defined to you as the problem, which is 0 to 24. That is only the even numbers, because we replaced all the odd numbers in one set with -1. So they're not in common between the two sets anymore. And thus you get just what is in the intersection set of the two arrays when you view the arrays as sets. So you can also get positions in which elements of two arrays match. So what I mean by position is now these are the elements that are in common between these two arrays, but the two arrays match at a position of 0. They do not match at a position of 1. They do match at a position of 2. So if you want to understand, if you want to get the set of positions, an array containing positions at which the two arrays match, then what you can do probably is, let me think about it. The best thing to do is your np.where function. So let's add 9 equals np.where. Let us try this. Maybe it will work. Maybe it won't. Add. Hopefully, let us see this. Yeah, you'll notice that the two arrays match. So, okay, in this, I chose a bad example because let us say the positions at which the arrays match are themselves also. So, for example, like I said, I was asking for where these two arrays match. This is the index 2, but the value of index 2 is also 2. So just to illustrate that better, maybe what I should do is I should try add 2 star 2. 12 equals star 2. So now I hope you notice that I multiplied both arrays by 2, so the numbers don't correspond to a situation where they are their own indices. And if I now do, just to illustrate, add 11 equals add 12. And if you now check what add9 contains, it will tell you the positions at which the two arrays match, which is these two arrays match at the second position, the fourth position, etc. And so you get these numbers. So this numpy.where is a very powerful function that I think you will end up using quite a bit if you start deciding to process large data sets with NumPy. Instead of going on with the next exercise right now, I will take a quick pause and I will ask if any of you tried out any of these exercises and faced any difficulties and want to ask a question now, you can raise your hand. Or if you have a question about anything we did so far today, please raise your hand. If you, hi Modish.
Good evening, sir.
Yeah, good evening. Tell me.
Sir, I will do machine learning thing in next. I'll ask about that in next lecture. I'm asking about you in previous lecture you told us about multiplication. So multiplication is different that we do manually, and that is done through this. It's a different one. So is there a way to do that also that we do manually?
Sorry, but
In multiplication of arrays, sir. Two arrays.
You want to multiply two arrays?
I mean, that was not multiplying in the way we do on paper. I mean, that how we have learned multiplication of two arrays. So it was multiplying the values only.
Sure. Oh, you want to take the dot product of two arrays?
Yeah, so that was dot product, but that dot product is not what we do. How do we?
No, but wait, let me try R1 and R2, add. This is a dot product, no? So let us just try MR. I'm calling it MR because I'm going to multiply with them. NP dot range of 3. Sorry, I should probably do a range of 3. And MR2 equals a range of 4, 1 column. I'm just declaring two arrays. Sorry, this is. So let us examine what these two arrays contain. First one contains 0, 1, 2, and second one will contain 1, 2, 3, I believe. Yes. Now, if I do dot product of these two vectors, arrays, what I should get is 0 times 1 plus 1 times 2 plus 2 times 3. So that is 2 plus 6, that's 8. And if I do np dot dot of R2, I get exactly that. I believe there is also np dot cross. Yes, mar2, and you will probably get, you will get, what is called the vector cross product, right? So I will ask you to, no, you are unmuted, right? Is this what you wanted?
Okay, so yeah, maybe that I'll check it then again, sir. Maybe I will ask that if that matches the answer. So
I believe if you want something like an outer product, which is, if you multiply two 1 by 3 arrays and you want to get a 3 by 3 array, there will be a way to get that also. Let me
see. I'll check that, sir, also. Okay.
Sure. So yes.
Okay. Another one is that, sir, is there a difference between these two brackets? One is parenthesis or the square bracket?
Yes.
So that we can remember properly.
Definitely, there is a difference between these two brackets in Python. Just to show you what that means. So here is 5. I give this, and let's try 1, 2, 3, 4, 5. Let us try these both things. I'm declaring them now. Type of A is a list, I believe, and type of B is, I believe, a tuple. No, it's a set. So the thing is that A is ordered, and I believe B will not be ordered because the set does not have an order. Let us try this out anyway. Just because it is declared, it will give you that in that order, but let us see, B of 0. Yeah, so a set object cannot be subscripted, whereas a list object can be. A of 0 will give you the first value, whereas you cannot call B that way because it is a set. What here, let us try maybe np.asArray tr3 equals array of B. Yeah, so you can convert both lists and sets into a Numpy array by using np.asArray. But like I said, in the Python standard library, the two parentheses are very different.
Okay. So curly bracket is also used in in function also.
You mean not in? I mean, you can use a curly bracket to denote the beginning and end of a function in Python, like in C++, but that is not the preferred way. The preferred way is to use indentation. I believe JCK has taught you this, right?
Yeah. So dictionary, sir. I guess dictionary was the.
Yeah. So if you declare a dictionary for a dictionary, you can use a curly bracket.
So set or dictionary are the same thing?
No. Set and dictionary are different things. So I believe if you do instead, let's say, let us try this. If you want to declare 1, 5, 7, 8, 9, I think this will be a dictionary. Let me try now. Sorry. Set and dictionary are two different things. They're not the same thing. If I do type of C, I will get a dictionary. So notice that if I declare something like this, I get a set. If I declare something with a colon in between, I get a dict. And the difference between a dict and a set is that one is subscriptable, the other is not. So to illustrate the point, I can do B of 0 and I will get an error, I believe, because set is not subscriptable. Whereas if I do C of 0, I will again get an error, but it will be a different error. So notice that the error is that it is not subscriptable. If I do C of 0, it is an error, but that's only because it does not contain the key. If I, on the other hand, do C of 8,
okay,
I will get 9.
Okay.
Do you understand the difference now? So,
yes, sir. Yes. And sir, about this parenthesis that we write like type parenthesis and C. And if you tell a little bit about this parenthesis.
Oh, this parenthesis.
Yeah, this one also.
Yeah. So if I do, let me try that. I mean, you should. Ideally, these are the questions you should just try these things out because I don't know them off the top of my head either. So let's try this one. I think I'll get a tuple, which is a different kind of thing. Let's try different numbers. I'm bored of. Sorry, this is now. I have made a multiple types, I believe. 7, 8, 5, 7. That is so. This works. Let us now try type of B. Yeah, so this is now a tuple.
Okay, fine.
Let us understand what the difference between a tuple and a set is. A tuple probably can be subscripted, yes. But actually, I'm not really sure what is the difference between a tuple and a list. Cat. Let us try this. Yeah, so I'm not sure what the difference between list.
D2, sir, D2. And maybe then it will be.
Sure. I'm sure it will show you cat if I do that. But my point is, I don't know the difference between a list and a tuple. So quite often you can use. So the main difference is this: A is a list, C is a tuple. Sorry, D is a tuple, right? So you can now do A of. So if you print A, you get a list, and you can now do A of 3 equals 7, and you can replace the value. So now if you do A, you'll notice that the third element, instead of 4, it is now 7, because you replace this. If instead you try to do that with the tuple, I believe it will complain. So let us try now. DF. It will probably give you an error, yeah. Tuple object does not support item assignment. So these are different ways. So I think one of the good things is that if you declare something as a tuple, when you iterate over it, it is much faster, because the memory is allocated to it in a different way. Those are the advantages. To be honest, I'm not familiar with, I've never used a tuple in any of the Python code I've written. But yeah, these are the differences you might want to be aware of.
Yeah, okay. Thank you, sir.
So just before, since we have 6 minutes left, I will show you how to import data from any file including on the web, into a Numpy array using numpy.gen from txt. So how we are going to do this is, so let us, so you may have a place on the internet where like this, where some data has been stored. You can go there, and unfortunately it will not allow you to visualize this data in the browser, because it has an extension .data instead of .txt file. So just to show you what it is like, I'm going to go to my downloads directory and look at what it is. Data, you see that these are a collection of numbers and a string. Now, in Numpy, what you can do is, oops, what happened to my collaboratory notebook? Yeah, okay, it's here. What I can do is I can assign the same address to a string, okay, and I can do now. I can directly load that data by using npy.gen from txt. np.gen from txt. So let us now see what the array iris contains. You notice that everything has been loaded, but as a string. And this is because I gave it the D type object. If I did not give it that, then maybe it would load everything as a, yeah. Now it is loading everything as a number, but the last element in each column, each row is not a number because, yes, well, it is not a number, it is a string. And Numpy does not know how to parse a string into a number. So these are, this is a very useful tool, np.gen from txt, especially when you're working in a collaboratory notebook and you're trying to download a data set and work with it. So I would strongly urge you to look at the different ways in this this thing can be used. So you notice that there are many options you can give in this, and those options will show you, for example, how to you'll find many examples of this function being used to load arbitrarily complex data sets into arrays. And it is a very useful, it's like what I'd call a Swiss Army knife of loading data. You can specify many of these functions, and depending upon that, you will get different outputs, all of them into nice structured arrays from data, and then you can do all the things that I showed you, like matplotlib, plotting, etc. So we have just 1 minute left, so I think I'll stop now. If you have questions, don't. I think the most important thing is to just open up a collaboratory notebook, try these things out. I will be saving this notebook and sharing it with you. Try everything. Every time you get an error, Google that error, try that solution. This is how you learn. In the next lecture, I will show you how to use SciPy and Matplotlib to do a slightly more complex data analysis exercise. And in the work session, we will try out more examples involving pandas and SciPy. So I think for the time being, that is sufficient, right? I hope there are no further questions. Are there any further questions? Right, well, if not, I'm going to stop sharing my screen, and I'm going to, well, I see questions in the chat. Okay, nothing relevant. So what I'm going to do is I'm going to leave, and I will share this notebook with Dheeraj, who can post it on the platform.